very good afternoon for everyone joining us from Southeast Asia, and a very good morning to those of you who are attending this session this beautiful afternoon from Europe. You are joining us for the 2022 edition of the European Research and Innovation Days in ASEAN. This is the 7th year in a row that we're putting on this event for you. My name is Susanne Ransovasu, and I'm here together with my wonderful colleague, Dr. Jenny Lind Elmacco. Hi, Jenny. We are the Euraccess worldwide team here in Southeast Asia, and we are part of a global network that is dedicated to bringing together researchers, innovators, scientists, policymakers from Europe and our global partners, so that you can join forces, you can exchange ideas, you can learn from each other, and you can build partnerships. This year's EU R&I Days are looking at the issue, the twin transition, green and digital, towards our sustainable development goals. We are already in the 2nd year of this event. We've already had hundreds of you joining us, so we're very grateful that you're joining us also this afternoon, where we'll be learning about top-level climate change research in Finland. Now, I'm handing over at this point to my colleague, Jenny, who's going to introduce you to today's moderator. And then I wish you all a wonderful session. Thank you.
Thank you so much, Susanne. Before I introduce to you our excellent moderator for today, guiding the discussion on top climate research in Finland, I just would like to flag to you that there are some sessions that are happening also. Like after this session, you have Spain as well. We will be talking about how renewables hydrogen drives energy transition in Spain. Tomorrow, we have also Austria and Spain again for other sessions. So please check the website EU-RI-Days-ASEAN.engage.eu to register for those sessions. So without further ado, I'd like to introduce to you our moderator for this session. He works as the Education and Science Counselor for the Finnish government to support international cooperation of Finnish education and science with global partners. And she's part of, and I know this because I always see this actually in the European higher education fairs and in other educational newspapers, this Team Finland Knowledge, which is a network jointly established by the Finnish Ministry of Education and Culture and the Finnish Ministry of Foreign Affairs, with the effort to increase the international connections, impact, and quality of Finnish education, higher education, and research. So thank you so much for joining us. To everyone, please help me welcome warmly the moderator for our session, the Counselor for Education and Science, the Embassy of Finland in Singapore, Anna Korpi. Anna, the room is yours.
Thank you very much, Dr. Suzanne and Dr. Jenny, for this warm welcome. And we're really happy from Finland also to be part of the European Research and Innovation Days also this year. And thank you so much for organizing and inviting us to be part of this. Like Dr. Jenny said, my name is Anna Korpi. I'm the Education and Science Counselor here at the Embassy of Finland in Singapore, but I have the privilege of having a regional role to work with science cooperation and education cooperation within the whole of the region of Southeast Asia. So really, it's my pleasure to be here today and happy that the audience have taken an interest in Finland. I'm really, really happy to again be hosting this session today, like we did last year, together with colleagues from the Academy of Finland, our most important research funding agency in Finland, as well as colleagues from the University of Helsinki and the Finnish Meteorological Institute. Without I give them the floor, I would just say just a few words about first Finland and also then the Academy of Finland. So we often do say that Finland is, as you might know, a small kind of cold country in the north, but then we like to also say always that we are actually much bigger than our size in education, in science and in innovation. And we are really strong believers in science and expertise to guide our, for example, decision making, policy making, and to build innovations and business opportunities to solve the problems. And today, of course, we are talking about one of the biggest problems facing us, the climate change, and really privileged to have some of our key researchers and sort of experts on this with us today. So the Academy of Finland is the key public funding agency for scientific research in Finland, funding high quality research, providing expertise in science and science policy, and strengthening the position of science and research in the society. The name is sometimes a bit confusing. Effectively, the Academy of Finland is the Finnish Research Council. The Academy of Finland's annual funding for research is approximately 450 million euros. And each year, the funding supports around 3,000 people's work at our universities and research institutes. So in this session, we will introduce some of the key research initiatives in Finland on the theme of climate change research. And with these, the audience, I hope you get an idea of what we are doing and where there might be some joint areas of interest and possibilities for collaboration. But now, before we talk about the initiatives themselves, I would first want to give the floor to Dr. Maiju Gyran, a senior science advisor from the Academy of Finland, to talk a little bit about one of the most major funding mechanisms of the Academy of Finland, the Academy program. So Maiju, please, the floor is yours.
Thank you very much, and good day and afternoon to everybody who is listening to the line. And I will put my presentation slide up, so just a second. There. So in my introduction, I will say a few words about the Academy of Finland, but more focusing on the programs that we have. And as already mentioned by Anna, that we are a governmental funding agency, and we have a various mechanisms through which the funding is granted for research. And these programs that are discussed also today is one of the funding forms that we have. In the programs in general, we have programs that are thematically oriented. So there might be one common theme where all the funding will go. For example, the climate change can be one of the themes, but there can be personalized health, there can be media elements, there can be digital humanities elements. So always some thematic area inside of the program. But in addition to those programs, we also have a bottom-up process programs where the researchers can choose the areas where they want to apply for funding. And that's purely a bottom-up basis from the researchers' side to see what kind of elements they are looking for the program. And in today, we will have a presentations from 3 different type of programs that we have in the Academy. And the first of them is the Center of Excellencies, where we are looking for the top-notch scientific quality of research, and always looking for the more on the impact side, the impact for the research and the research community. So really top-level, high-quality research in the Center of Excellencies. Then the other program that we are having a presentation from today is the flagship program, which is having a combination of the top-level research and a plus to that is the impact. So impact for the economy or the impact for the society. And for the flagships, we already say that they have to have impact for the wider community, not only to the scientific community as such. So the angle to view is a bit different from the centers to the flagships. And then we have a third program is on a thematic program side. So we have a program dealing with the climate issues and climate synergies between different elements and topics under that umbrella. And we have a presentation from there. And usually the thematic programs are, of course, science driven, but always there is some need that is coming from the society, and the program elements and the research that is done under the program is targeted to have a solution for those programs that are under that program. you can see the funding volumes roughly that we put for the programs, and maybe to point out that these programs are for long term. So for the centers of excellence and for the flagships, even the contribution and the investment from the academy side is for 8 years. So meaning that the researchers really can have a long-term vision on the science that they are doing under this umbrella of the programs. But I think with further ado, I will hand over back to Anna and have floor to our researchers. Thank you.
Thank you, Dr. Maiju. I think just before I let you go, I would like to, like you already mentioned that the climate change is obviously a topic of many of the projects in these programs. But is there something the Academy looks sort of more cross-cuttingly about, for example, including this theme in all of your funding decisions, for example? How is climate change actually taken into account?
As a topic for the programs, of course, since when we are building a program, we have these kind of thematic areas where we like to see the applications fit into, and therefore we always pick the ones that are having the answers and related research for the questions that are key for the programs. But for these programs that are purely bottom up, in those it's always based on the scientific competition, and it's always based on the topics that the researchers are bringing to the game. So in those programs it's purely science based and not any area priorities in that sense.
Right. Thanks very much for that. And if you have any questions for us, for Dr. Maiju or any of the other presenters, please post them in the chat, and we will try to take some questions from the audience also for the end in the end of this session. But now I would like to kind of move to the topic itself in details. And as we all know, the climate crisis is really an existential crisis for the humanity, and many of the solutions that we really need are actually yet to be found. And we really turn to the science for those solutions. And that's why this theme is so important in many of the research initiatives. And in Finland, like I said earlier, we take this very seriously, and both on the policy level as well as in research and innovation. So let's indeed now look at some of the key research initiatives in the field of climate science. And I will first, actually we will first take a look at a short video and then give the floor to Dr. Hanna Lappalainen.
We have several environmental grand challenges: climate change, air pollution, food supply, fresh water supply, biodiversity loss, and all of them are interlinked. In our flagship ACCC, we aim to solve and contribute solving of these issues, from deep understanding to practical solution to help humankind to be alive also in future.
So to talk about this very interesting research and research ecosystem, actually, I will give the floor to Dr. Hanna Lappalainen from the University of Helsinki. Please, the floor is yours.
So my name is Hanna Lappalainen, and I'm from the University of Helsinki, and I'm working as an impact coordinator in our flagship program called Atmosphere Climate Competence Center. And we are 4 partners, University of Helsinki, together with Finnish Meteorological Institute, Tampere University, and University of Eastern Finland. And academician Markku Kulmala is the director of the flagship. And we are active in years 2022 until 2024, and then we're looking for the next 4 years of continuation for the flagship. And our academic funding is around 11 million euros for this period. As Marco already described in this short video, our mission is to make a contribution toward achieving carbon neutral society in Finland, Europe, and globally by finding out the ways to take CO2 out of the atmosphere and verifying it. And the second important topic in our flagship is to understand the atmospheric pollution in detail to quantify the impact of reducing pollutant emissions on climate and to mitigate air pollution and sustain healthy atmosphere. And our mission is contributing the Paris climate targets and EU Green Deal and also the United Sustainable Development Goals. Our background is on international top science on atmospheric and earth surface interactions and sciences. So we have had already a long period of Finnish Center of Excellence in this field, starting already 2002, and we have published already something like 50 nature and science publications, and we host 16 European Research Council projects. We are multidisciplinary community and have wide global collaboration network in altogether 800 institutes in 55 countries. And we have also initiated our own programs called Plan Eurasian Experiment Program and Global Earth Observatory Global SMARE Initiative. We have also a leading role in developing European research environmental research infrastructures on carbon observation, on aerosols, clouds, and trace gases, and also ecosystem research infrastructure. And we have also increasing business collaboration and new spin-offs. And one important aspect of our approach is also science diplomacy. We have worked very close collaboration in Chinese research organizations. And also we are very active in the Arctic region. Short overview of our organization. So we are a community about 700 research coordinators, technical experts working on atmospheric sciences. And if we look at our scientific and impact advisory board, we have representatives around the world. So for example, from China, we have academician Guo Huadong, who is working as a United Nations Science Advisory. And we have also representatives from US and also from European countries, and have members who have world-leading expertise, especially in aerosol research. And then I will move on to this program. So our approach consists of 3 research programs. First is on potential of land-based climate change mitigation. The second program is focused on air quality climate interactions, and the third one on climate change impacts and adaptation. And around these 3 specific research programs, we have identified 13 different impact task forces where we collaborate very closely with different stakeholders. And these impact task forces vary from carbon sinks and agricultural land and understanding the forest stocks, soils as a carbon sink. And then we work with the companies on their carbon neutrality and how they can compensate. And then we have an urban aspect and work on climate neutral cities and health issues. And then we are very we have an expertise on developing atmospheric observation and technology and instruments. So we have novel edit technology, observe carbon seek, and we collaborate with Vaisala company. And then we work, as I already said, that ASEAN collaboration is very important for us. So we are working with the megacity air pollution issues, and there we have also this Pan-Eurasian experiment program with a wide research network in this area. And then we try to develop and promote Global Earth Observatory in the field of atmospheric ecosystem observations. And then also this so-called climate university, which is a massive online education based on our expertise. And we work in many different platforms or environments. We work in cities and especially in megacities. And then we are interested in agricultural lands, peatlands, and forest lands, and their understanding the climate interactions and how what is the role of these surfaces in carbon balance in the regional and also in the global scale. And in our approach, we combine several different methods and data coming from satellite and ground-based stations, and we combine that information in our models. The first research program is focused on forest, peatlands, and agricultural lands, and I will not go into the detail. But anyways, this program is studying these climate impacts on land use and forestry, including greenhouse gas balances, albedo and aerosol cloud climate interactions, and we try to understand them in boreal and Arctic ecosystems, and how we can quantify these greenhouse gas balances for different surfaces. And one important focus areas is also this agricultural lands and carbon budget of farms. And for this specific research program, I would like to address that we have a very important research infrastructure located in Finland, in Hyutiala. There we have so-called comprehensive observation station for measuring ecosystem and atmosphere relations. And this research infrastructure and station setup enables us to measure over 1,200 parameters per day. So we have a massive data pool measuring this kind of system, and we are promoting this stations concept also in our networks. And Markku Kulmala has published this comment paper in Nature called Build a Global Earth Observatory, and this is based on this Hyutiala research infrastructure. And here is some photographs from Hyutiala. The second program is focused on urban environments and megacities, and it's focused on origin and impacts of air pollution with diverse approaches. And the core of these studies is on a role of traffic, both as a major emission source and regulation area for impact assessment. And we have especially new findings on and new information on atmospheric aerosols in urban and agricultural environments, and understanding the influence of new particle formation, local emission, urban morphology, particle growth on pollution in megacities. And we have already made a detailed response to European Union Commission questionnaire and revision of the Ambient Air Quality Directive. The third program is on the society aspects, how climate change affects on societies, and their key topics are impacts on land and aviation, energy, sea, ocean, preparation for new climate law, and collaborating with Climate University. And Finnish Meteorological Institute is coordinating these specific tasks. And then, as I told, that we have this impact program where we have these 13 specific task forces, and they are closely connected to research programs and each others, and also collaborators outside ACC community. And they are very different type of task forces. Some are built on previous projects, initiatives, and collaboration. And they are forms of programs, projects, and networks and forums. And here is some overview of our stakeholders. This list is based on what we had in the beginning of this flagship program. And that time we had something like 40 stakeholders coming from public-private sector, and representing different organizations and research infrastructures, but at this point we have already increased this number of stakeholders. I will show some insights of our success stories. So I would like to address here this success story on climate impacts on agriculture. So the idea is to develop methodology to estimate carbon sequestration and other climate impacts on agricultural land for greenhouse gas inventories, carbon markets, and carbon footprint assessments. And this work we have established state-of-the-art field measurements and use and combine different measurements and collaborate with developers of new measurement technologies. And this the aim of this and outcome of this is contributing climate policy, carbon markets, carbon footprints, and other service development. Another success story is on improving and standardization of nanoparticle measurements, and there we have had a long collaboration with an Air Modus company, which was a spin-off of our institute. And the idea is measuring particles smaller than 10 nanometers, and this is very important, understanding the particle formation and growth processes, and for the urban air pollution, and how to make effective control and regulation in this area. And we have made some progress in several areas related standardizing and improving the measurements. The second example is on the mass spectrometry, and we have a global leadership in atmospheric mass spectrometry, and this development is based on this atmospheric pressure interface time of mass spectrometer called APITOF. And this work has been making close collaboration with the company Topfrank and Iron Research, and also continues with the CERN Cloud Atmospheric Simulation Chamber collaboration. And this APITOP is very powerful measurement instrument, and we can elucidate the compounds responsible for the first steps of new particle formation. And we have carried out studies around the globe in Ireland, Irish Atlantic coast, Antarctic, and Beijing, and make some new discoveries in this field. And our future idea is combining multiple mass spectrometer technologies for us even closer across huge diversity of organic compounds engaging in aerosol formation. And then one example more is this Climate University, which builds on everything we do in the ACC in our research programs, and we built this new massive online education modules, and they are freely available from the net. And at the moment we have 9 online courses, and the next one will be published on biodiversity by the end of this year. And we are upscaling this approach and have an international collaboration at the moment in European Union level. For the future outlook, here is a picture of our ecosystem. And as you see that we are working in many dimensions on research, policy dialogue, business innovations, knowledge transfer, and research infrastructures in several scales, national and international. And the work in progress is that we are preparing this atmosphere climate competence center ecosystem and roadmap description, and this would serve our stakeholder collaboration to provide a better understanding of our approach and attracting more collaboration. Some take-home messages: we are a community of 700 researchers, coordinators and experts working in this field, and our ecosystem in atmospheric sciences is in vital collaboration and dialogue with increasing number of stakeholders in and outside Finland. And if we are able to, for example, in the 8-year time window, with this flagship instrument, we are enabled to consolidate our ecosystem and our research and innovation ecosystem in atmospheric sciences and recognize as world leaders in this field. I think that was all. Thank you for my side.
Thank you, Dr. Hanna. That was a very comprehensive view into the ACCC flagship. As you mentioned, the University of Helsinki and your whole actually research ecosystem has already been one of the world leaders in this for even before having this flagship program. But from your point of view, why are still sort of initiatives like this that the Academy of Finland has launched, why are they still needed to kind of boost our research activities and capabilities in like, for example, in your field?
This flagship instrument gives us more resources to really upscale the previous work done in several years in our Center of Excellence. So it's very important for upscaling and for bringing this kind of knowledge to international scale.
Thanks very much, and I think this is an excellent example of the excellence in Finland, but also the kind of applications and the future prospects. Now I will turn to the next sort of center of excellence in our ecosystem, which is the Center of Excellence of Inverse Modeling and Imaging, and I will give the floor to Dr. Marko Laine, the research professor from the Finnish Meteorological Institute. Please.
Just a moment, it's yeah.
Okay, so hello everybody. So I'm Marko Laine, I'm a research professor at the Finnish Meteorological Institute, already mentioned a couple of times in the last presentation. But here I will represent the Academy of Finland Center of Excellence in Inverse Modeling and Imaging. So as already stated in the beginning by Dr. Maju, and as the name says, the Center of Excellence programs aims for scientific excellence. The CEO program funds cutting-edge science in their fields, also taking account the social impact. The Center of Excellence in Inverse Modeling and Imaging has members from 7 Finnish universities and from Finnish Meteorological Institute, where I'm from. The people involved are applied mathematicians and mathematically oriented scientists we already have a quite long history of active collaboration. The methodological and theoretical focus areas in the center are nonlinear partial difference equations, geometry, and uncertainty quantification. It's quite easy to say that this center represents the world-leading research in mathematical inverse problems. Well, Finnish Meteorological Institute, so FMI, is a governmental research organization doing scientific research, but it's also the main meteorological office to provide weather forecast and warnings to whole Finland. The active research topics at our institutes include climate research, meteorological research, research in air quality, space research, and marine research. The strategic aim is to do research and provide services for the safety and success of the Finnish society. It could be said that the role of FMI in the Center of Excellence is quite unique in the sense that we are doing both doing and developing mathematical and statistical methods, but we also provide interesting and important applications and research questions to other partners of the COE. So I start, I have a couple of examples of the kind of research problems that we do, and I start with the descriptions of very typical inverse problem that has a direct relevance in climate research. And this example is provided by satellite remote sensing. FMI has worked in collaboration with NASA and its orbiting carbon observatory satellite OCO2 that was launched in 2014 to monitor global atmospheric carbon dioxide from space. In the inverse modeling terminology, we speak about direct models and inverse models or inverse problems. In the case of remote sensing from space, the physics of scattering and absorption of light is relatively well known given the actual constituents in the atmosphere. But the inverse problem is more difficult. We are given the spectrum of light that has reached the satellite sensor after reflected from the Earth's surface. After seeing what the instrument measures, then we need to infer what is the amount of CO2 and possible of other constituents in the atmosphere. This is a quite typical so-called tomography problem that is much studied in the inverse problems research. It has typical features like it's ill-posed in the sense that the solution is not necessarily well defined or it's not numerically stable without some prior information on the solution. The unknown amount CO2 is a continuous atmospheric state. So in principle, it's an infinite dimensional object, which typically leads to very high dimensional numerical problems. But I continue with giving with this OCO2 example. So satellite data is and will be very important for the stocktake process of the Paris Climate Agreement, as it provides objective data on the greenhouse gas emissions and sinks. In this example, we have a novel climate research based on OCO2 data done at FMI by Janne Hakkarainen. Here the figure shows anomalies of CO2, so deviations from the mean values that are averaged using several years of OCO2 measurements. It's also value X CO2, which is the vertical column average CO2 at each pixel location over land. What the data reveals already is the sources, both anthropogenic and natural, of carbon dioxide. For example, we can see biomass burning in equatorial Africa. We see the effects of deforestation in South America. It also shows the sources of CO2 from industrialized areas, such as Central Europe and China. We could even see some smaller individual spots like one in Southern Africa. The new satellites that will be launched in the next few years will provide even better resolutions, enabling unprecedented accuracy for detecting individual sources of emissions. Well, this is my second example of the research topics that we are involved in. The previous figures showed a single source of measurements from the OCO2 satellite, but there are enormous amount of monitoring data already available from different environmental satellite missions, from automatic in situ monitoring systems, from citizen observations, and so on. As we saw already in the previous slide, satellite data is especially important as it gives a global and uncensored view, and then can be used to verify inventories based on stakeholder announcement, for example. So methodologically, we need efficient methods to optimally combine observations to be used in decision making, for example, to see the effects of different adaptation measures. There are several research projects going on related to data fusion. Here the figure shows one example of water quality in the Baltic Sea, utilizing both satellite and in situ measurements. Top figure is the satellite data of on 1 day of chlorophyll A, so giving LC concentrations. Data is incomplete due to cloud, so we need spatial temporal interpolation methods. And the bottom figure shows the time series of fused results in one location. In the last bullets in the slide, I mentioned some specific topics like developing high-dimensional filtering and smoothing methods, as well as using deep learning methods to learn the dynamical processes that are needed in the spatial temporal interpolation. This is an example of results done in collaboration with Aalto University in Finland and also with the Finnish Environment Institute. So with these two examples, which only present a small part of what we are doing in the center, I conclude with some remarks. So Academy of Finland Center of Excellence in Inverse Modeling and Imaging does mathematical research that has relevant in climate science too. Finnish Meteorological Institute benefits the interdisciplinary collaboration with the center. And as you saw, satellite remote sensing, well, it provides very interesting methodological challenges that can trigger new development in mathematics, but it's also essential to monitor climate change and verify mitigation measures. So that was all from my side. Thank you for your attention.
Thank you very much. I think that's very, very sort of informative when we can actually see the emissions coming from on the map. That's actually something that we can run away from, actually. Just one more question for Dr. Markot. I think some of our Asian audience would be interested to know how do you, for example, for the Finnish Meteorological Institute or through your programs in general, how do you recruit researchers or colleagues to the team, and what qualities do you specifically look for when recruiting Finnish or international talents?
Yeah, as you saw, there are many universities involved, so naturally all the universities and the teams within the universities, they have their own recruitment policies. But all of them, and including FMI, are constantly looking for talented people to work on these problems. So those who are interested should check the web page of the corresponding institutes. For FMI side, I would say that the new trends in science and computing are very much related to the new computationally intensive methods like machine learning and data analysis in general, and those are the skills that are needed in many research areas today.
Thank you very much. I would like to talk about this more, but since we still have one more presentation, I think we have to go on and give the floor to Dr. Juha Helenius, professor from the University of Helsinki, from the Strategic Research Program Food towards a Sustainable, Healthy and Climate Neutral Food System, which is equally intriguing. The floor is yours, Dr. Juha, please.
Yes, sorry, I was muted. I'm attempting to share my screen with you now, and it doesn't seem to work.
We see your screen, and now at the moment just not in the presentation mode. So could
exactly. All right. Now it's improving. How is it now?
Now it's in the kind of, if you put it off the display, the kind of present,
Right, now it's good.
Yes.
Sorry about this.
Excellent. No worries.
Sorry about the delay. Yes, thank you for the invitation to present here. My name is Juha Helenius, and I'm the program director of the strategic research program Food, which refers to the research program towards a sustainable, healthy, and climate neutral food system. About this strategic research, it's administrated by the academia, so the Finnish Research Council administrates it, but strategic research is an instrument which is directly set by the Finnish government. It's an instrument for the government to ensure access to up-to-date scientific information on which they can ground their political decisions. And for this purpose, the Finnish government has set a strategic research council, which is a group of top experts, scientists, but also politicians and other stakeholders who discuss and set and propose to the government the themes on which research should be carried on under this instrument of strategic research. Unlike the former two programs, this is kind of very specifically focused on topics that the Finnish government sees essential to explore scientifically for the purpose of the Finnish policies. This does not mean that the strategic research would not be internationally interesting. In our program Food, for example, we are all the time publishing, or all our research are published in internationally highly valued journals. So just to close about this strategic research, I would like to mention that now ongoing, we have 13 research programs in Finland. Under this, Food is just one of those programs. And these 13 programs host 54 research consortia, 54 projects, which are very big projects of involving practically, I would say, all the universities and all the research institutions in these 54 research consortia, with of course very varying compositions. But it's very covering system, and the topics of these 30 research programs vary from, for example, this digitalization in the society, which is one of the topics of today's seminar, to let's say to food, which is our program. Very, very many topics ranging from natural sciences or more natural sciences oriented research needs to social sciences oriented needs and so on. So this strategic research program Food towards a sustainable, healthy and climate neutral food system started in 2019 and runs until 2024. Usually these are 6-year projects which are being evaluated mid-term. and food just got into its second funding period. Food consists of 3 research projects, and I don't know if these slides will be shared somehow, but I have included active links in this slide to these projects, but you can also find these projects simply by Googling by the name. So in alphabetical order, the first project in our food program is Just Transition, which looks at tackling inequalities on the way to a sustainable, healthy, and climate-neutral food system. The other one is addressing legumes for sustainable food system and healthy life. Those of you who don't know what legumes refer to, they are plants, and they are especially a family of plants which are able to fix nitrogen directly from the atmosphere, which makes them very exceptional. We know many legumes as food plants. They are called pulses, the food grain legumes, and also as feed plants. Like clovers are popular in Finland, alfalfa in many other parts of the world as feed, roughage feed for cattle. So both food and feed plants, how to use these exceptional plants that can fix nitrogen in the best way, also to reduce, to mitigate climate change and to adapt to the climate change. And then the third project under this food program is looking at multi-benefit solutions to climate-smart agriculture, especially addressing what has already been mentioned by Dr. Hanna, the carbon capture in agricultural soils. Our program shares, the food program, is the shared understanding of the concept of food system. Here I used, it's very crowded slide, sorry about that, but you can see that the food system is quite much more than just the food supply chain. We often conceptualize the food system as simply as the food chain from farming through processing and marketing to us consumers. But the whole system, in understood the way we do in the food program, this slide is from the FAO's high-level panel of food security. We understand it this way. So it is all that is linked to the technologies, to the policies, to the cultural issues, to the institutions, which ensure or do not sometimes ensure that we have good food and nutrition available at all times. And in looking at this, the climate change in our program Food is a cross-cutting theme, so that we, in each of these 3 projects, we have elements that look at impact assessment. How does climate change affect the food system, be it natural sciences impacts like changing climates for food production in agriculture, or social impacts in the society. We look at the mitigation options variably in the 3 different projects, but all look at the mitigation options in different ways. And then we also look to adaptation possibilities and challenges as cross-cutting socioeconomic, environmental, and technological challenges in our society. And I would like to end with a few examples of climate change research in food, with bullet points list. We, for example, and this is in close connection with actually FIM, if you remember the presentation by Dr. Marco, FIM is a partner in this Multa project, and we directly employ the methodologies and mentioned also by Dr. Hanna, the methodologies for measuring, verifying carbon capture in agricultural soils, for example, in this Multa project. And then this has an important application to look at the potential for carbon trading for agriculture. Also, this has been a challenge all over the world. We do not have, before we have verified quantification of carbon capture to soils in farming, the farmers are not able to trade their carbon. The Multa also looks at regenerative farming practices, starting from the point of view of capturing carbon to the soils, which in other words means maintaining the organic matter in the farmland soils, in the mineral soils. This also should add to biodiversity as well as diversity of foods. So the regenerative farming is a concept that looks at multiple simultaneous benefits from adapting the farming practices to mitigate the climate change and to adapt to climate change. Then the Just Food project, which is about the social justice and fairness in the food system, for example, looks at the socially just transition away from using deep peatlands, which have high net carbon emissions, to stop using these for farming. And this is a really, really big political challenge, because we, as some Asian countries as well, have lots of deep peatland soils which are being farmed. They are trained and they are being farmed. And we all know that if we train peatlands, they start decomposing, and carbon dioxide emissions are huge. And this is a problem, social problem, and they look in this Just Food project the ways to negotiate and to find fair solutions, how the farmers who are currently farming these soils, how can they switch away from farming the soils? Because the only effective method to reduce the huge emissions from these soils seems to be to not to use them for food production. And then Just Food also looks at just transition towards climate-friendly diets as another example. And they have, for example, produced as an impact output to the society, they have produced a brochure or guidebook for climate-friendly school meals, which has been very popular output from the project. And behind that is, of course, there is top-level life cycle studies on climate impacts of different foods and top-level nutrition research on how to compose climate-friendly diets. Then the third project that I mentioned looks, for example, the use of pulses to replace excess meat in diets. And this is, of course, linked to the fact that we know that meat consumption, getting the same amount of calories and protein from meat meal causes, from the life cycle perspective, much higher climate emissions than getting the same energy and proteins from plant-derived foods. So there is a political maybe I exaggerate if I say consensus, but there is a political discussion about making this shift and need to find the ways how to also for nutritional health, which is correlated with reducing meat for these causes, how to do this in a just way in the society. And then another use of these legume plants is to use them as feeds. And in using them as feeds, we can reduce outsourcing of protein feed to livestock, which refers, for example, to the problem that Finland, also Europe, some Asian countries are importing lots of soya from areas where soya is grown so that it replaces the tropical forests. And in not using this soya that causes this climate impact through replacing tropical forests, instead using domestic protein feed sources for livestock, that would have a significant impact in removing the shadow effects of our Finnish food consumption. And then use of legumes and especially using their biological nitrogen fixation in reducing need of industrial fertilizer nitrogen inputs is a topic in this Leg for Life project also. And this reduces the carbon or the climate impact of farming via reducing the need for nitrogen fertilizers that are produced industrially with high emissions. And I think I remain here. The Leg for Life also looks at the reducing rumen emissions from dairy cattle through use of legumes in roughage mixers and so on. So there are many examples in all these three projects. Thank you.
Thank you very much for that. We'll only have some closing words to take in the end, but there is a question on the Q&A just for Dr. Juha, for you. So I will take this time to ask it live here. So somebody, Emil, is asking that they have received an Erasmus grant together with some colleagues from the Tampere University on food waste management. And the question is that could we then collaborate with your research group in the future also, maybe within the same consortium?
Yes, that we would be really happy to be in contact and discuss this possibility. As I said, our network, research networks are wide, and we have international partners already in food. So if you can, for example, contact me as the first contact, and then I see how we can achieve a nice cooperation.
Thank you very much for that. And now I will take on Johanna Hakala, who is the Manager of International Affairs at the Academy of Finland, to give us some sort of final calls to action for our audience for this. So Johanna, as we have researchers and scientists from Southeast Asia today with us, what would be your advice on how to proceed if one became now interested in these initiatives or other activities, other expertise in Finland?
Yes, thank you, Anna. It's a pleasure to be here with all of you today. So I'm going to briefly describe the opportunities. For students, I would suggest exploring the Study in Finland website, where you can find all the information on Finnish study programs in English, including doctoral programs. And I assume those links should appear in the chat section right now. And you should also be able to see all the links that are relevant for today's session in a slide that lists all of them at the end of this session. So for postgraduate students or doctoral level students and researchers, I would advise to check the website of the research programs we have presented. You will also have all the links in the chat and on the slides, or to go directly to the websites of the Finnish universities or research institutes and to get in touch with the research groups or professors. Connecting with the Finnish research groups is very important, especially because Finnish universities usually require that the doctoral student has the backing of a professor before applying for a doctoral student status. The supervision can also come from a professor from the research institute, but of course you need to be in touch with the university as well. The doctoral programs usually don't have any fees, but to cover living costs, you can apply for the paid position of a doctoral student at the university, or maybe the research institutes might have some funding. And one important source for doctoral students from abroad is the Finnish National Agency for Education, which provides personal grants for doctoral students from abroad. However, the applicant must be the PI in Finland who's hoping to have this doctoral student in their group. So you can't apply directly, but via the research group. Also in the postdoctoral phases of the research careers, you need this connection because, for instance, the Academy of Finland, as you have heard, which is the biggest external funder of basic research in Finland, it grants funding only to individuals and groups that are connected with the Finnish host organization. And also, these researchers must be willing to do the research mainly in Finland. Of course, you can make short trips to other countries during your stay here. And then last but not least, a great place to find information about opportunities to have a funded doctoral position or another position is the Euraccess website. So if you choose Finland among the countries and you can choose the relevant research field, you can see what jobs are available there at the moment. And now I will give the floor back to Anna, who will say a few closing words, and I think you can now see the slide with all the web links, or at least soon. Thank you.
Yes, thank you, Johanna, and thank you for all of our speakers. Indeed, you have both the slide with a lot of links and also the links on the chat. Please feel free to explore those further as you have time, and also don't hesitate to contact the colleagues on this event or even us at the Embassy of Finland if you have any questions on these. And I'm sure, at least we hope that this session has kind of brought in ideas for further cooperation, and we do hope that you can sort of proceed with them later on with these. But without further ado, I think we are already a bit over time, so we will close this session with thanking everybody for the attention, and also for the colleagues from Finland to participate, but also especially for the Euraccess for hosting us today. So thank you very much, and I hope everybody here in Asia a very good afternoon and good day for the colleagues back in Finland.
Yes, thank you so much to all the speakers and the panelists and for everybody attending. Just so that you're not worried, we will share the recording of the session and the slides, especially the last one with all the links, where you can read up on the many opportunities you to get in climate change research in Finland or with Finnish partners. And Jenny and I, of course, are here in the region. So if you ever would like to be connected to someone in Finland, a university or a potential supervisor, just drop us an email. Thank you so much, everyone. And we hope to see you all very soon and have a wonderful day in Finland. Thank you so much. See you all soon.
Thank you. Bye-bye.
Thank you. Bye-bye.